So the first lesson that I have on the worksheet, we just have hopefully in last class, work with Georgia, learn what a line segment was. What's a line segment? Yeah, just part of a line, right? So it has an end and an end, two ends, just part of a line. So we're just going to go through this example to demonstrate how we want to do stuff with segments. So here we got locations of cell phone towers. So we have cell phone towers, two towers, so a bunch of cell phone towers, and what we want to do is we want to reinforce the network coverage, cell phone network coverage. So we're given positions of towers based on coordinates. So 0, 0 is our origin. So that would be one tower. The other tower is 0, 10, so it's 2, 4, 6, 8, 10. So what we want to do is we want to find the middle of those 2 points. So if we treated the distance between these 2 points, or we connected it, we have our line segment. So what we're looking for is how can we find the middle of that line segment? So you can do the same on yours, plot your points, 0, 0, 0, 10. How do you find the middle of that line? Yeah. Yeah, but where is it?
Right middle.
So where would that be? 5?
It's 0 and 5.
Yeah, it needs to be a coordinate, right? We need an x and a y value. So what's the x value?
0.
What's the y value then?
5.
So 5 takes us right here. Right? Just right in the middle. Okay, we have 2 other towers at 2, 4. So 2, 4. Right there. And 8, 4. So here we have their line segment. How do we get the middle of that? How do we get the middle of that line segment? 8 minus 2 over 2. Over 2? So what's 8 minus 2? 6?
Yes.
Over 2 is 3?
Yes.
So x coordinate is 3?
Oh no, then add that to
I agree with that.
Not quite. Like 8 minus 2 is 6
plus
divided by 2. So we want to add 2?
well, it's 5. But
Well, how do we, okay, visually, how do we even know it's 5?
We don't.
it's in the middle.
It's in the middle, so I mean, even if we start our endpoints, if I go over 1, over 1, over 1, over 1, over 1, over 1, I eventually get up to there. Right, so what's the coordinate of that?
5 is 5.
It'll be 5, 4.
Then how do we explain
But how did, but is what Jordan said, would that work as well? What's 8 plus 2? And then take that divided by 2. What do we get? We do get 5. Right? So that works for an x coordinate as well.
So you get the difference and divide it by 2.
That's the difference. You need to add them.
Just like the average.
I was just about to say that. Thank you, Elizabeth. So it's almost like you want your average of your x values, right? And that came across in what other unit that we talked about? We're figuring out what?
quadrant?
And what we're trying to figure out.
The maximum, minimum.
Or what passes through that magical line that we call the
symmetry.
axis of symmetry, right? Remember when we had our 2 x points or x intercepts, right? We want to find the average of those 2 x values to get the point in the middle. So same idea over here, right? We want that point in the middle. But because it's just a horizontal line, the y value doesn't change. And then the last example here, we have 8, 2, which is over here, and 10, 2. So where's the midpoint of that segment? That one's really easy to see. What's the coordinate of that point?
9 and 2.
Okay. So questions B and C just asks us to How do the y coordinates of the new towers relate to the y coordinates of the other two towers? You sort of touched on that. What's the relationship that we see there? So what's the relationship that we see with the y coordinates?
Average.
Yeah, it's the average.
Oh,
Well.
Between the 2 points.
So it's just the average of two y values, of y coordinates. Of our endpoint.
Oh yeah, if I would delete everything.
Right? Well, how about the x values, the x coordinates?
x coordinates are irrelevant, but they're also.
Well, okay, but if it's a horizontal line,
It's
What was that say?
average of the two y coordinates
Of.
of our two endpoints.
Oh, okay.
Well, it's still the average of the two.
Yeah, so that's a good point that Jordan made. Even though in the horizontal line, what's the average of two numbers are the same?
Same.
Same, right? And it makes sense, right? If we have a horizontal line, the y value is not going to change. So with a vertical line, what do we know with the x coordinates?
It's average.
It's average as well, right? Of the x coordinates. Here's another example. We got one tower at 2, 1.
That's okay.
Another tower at 6, 9. How do we find the middle of those two towers? So here we got 2, 1, which puts us right here. At 6, 9, so 2, 4, 6. 9 is up here.
Wait, where do you get the two black ones?
Sorry?
Where do you get the 2 and 1 and 6 and 9?
I just made up those towers. So let's say we have two cell phone towers at those coordinates. How do we find the midpoints?
What are the coordinates?
2, 1, 6, 9. Average of what?
6 and 9 are the other. Is the other one? Oh,
69.
Okay, so what Amy says is we just take the average of the x and average of the y. Okay, so over here,
So 2.
what's their x values?
4.
What's their x values?
4. Or 2 and 6.
2 and
4.
6, so 2 plus 6 over 2 is equal to 8 over 2. So we plot 4.
I found it.
That's the word around here.
4 and
And what about the y values?
5.
1 plus 9 over 2.
1 plus 9 over 2, I know that's what you said, Dale. Equal to 10 over 2. Equal to 5, so 5 is right there. We find where they intersect. That gives us right there, so that's 5. Oops, is that 5? No, 4, 5, 5. Does that look like a midpoint?
Yes.
So if I actually connected it,
Right.
it would have gone right through the midpoint. Okay? Any questions on the midpoint? So what we do is just really find the midpoint of the horizontal and the midpoint of the vertical. Right? The average of the two things.
24 is 12.
So what's the midpoint of C? So we got 14 plus 28, so 38.
Okay.
Over 2.
12 plus 26.
So what's that?
Chotis.
52 over 2. 26. And y is just 11 plus 11 over 2 is equal to 22 over 2 is equal to 11.
I'm not doing all those steps.
So therefore it's 26 over 11.
Which is
Question? So our general equation, we want the midpoint is just x1 plus x2 over 2. Right, so I have 2 points, x1 comma y1 and x2 comma y2. We just take the average of 2 points. So our average over 2 coordinates. So because this is a point, we need the brackets around it because it's an x value and a y value. And we can denote midpoints with a capital M. Pretty easy formula to remember, hopefully. Okay, so let's quickly do the backside. So how can we find the midpoint of a segment that's formed by points 5, 1 and negative 12, 3? How are we going to do that?
Right before me.
Michael?
Write it out.
Okay. So the formula again was,
X1
Bracket.
well, M, right, the midpoint is equal to,
x1 plus x2 divided by 2.
x1 plus x2 divided by 2, comma, y1 plus y2 over 2. Does the order matter, x2 or x1?
Nope.
No, because we're just adding, right? So here I'm going to label my points. I'm going to choose this one to be x1, and this one to be y1. And over here, this will be x2, and this will be y2. So just sort of like trigonometry, right? Just going in and plugging in our numbers. We got 5 plus negative 12 over 2, comma 1 plus negative 3 over 2. So that gives us negative 7 over 2, comma negative 2 over 2. You want to leave my answer like that?
No, I hate fractions.
Well, one fraction is okay. The other one is not, right? We want to simplify this one over here.
What if we simplify both?
Sorry?
Can we simplify both?
No. So negative 7 over 2 over 1. The reason I say no is we're going to be doing a lot more with these points afterwards. So it's better to work with numbers as a fraction. So we get more exact answers. Okay. Any questions on that?
Are we going to show, like, see how you have the extra step to put it to -1, the -2 over 2 to 1. You have to show.
If you went to straight to -1, that's fine. Okay. What about the second question? How do we go solve that? So for this one, we're actually given the midpoint. So here we have an endpoint that's 10, 2. My graph looks really bad. Somewhere around there. And we're given the midpoint, 8, 5. 8, 5 looks like somewhere over there. So that's the middle of our 2 points. Can we sort of see roughly where the other endpoint might be?
Yeah.
Somewhere over here? Somewhere up here?
No.
Where?
You
Over here?
Make it straight. Get it
Yeah, we
make
could
a straight
actually
line,
make a
right?
straight line, and we can see that it's going to be somewhere over there,
You
right?
can also
So we could connect our 2 points, keep extending the line. It's going to be somewhere along there. You got 6 something?
you can use like rise over run.
We could use a slope, or you just take a ruler here and just. But using the slope won't actually get us another midpoint. Actually, it would. Actually, it would. Because actually, what we're doing is actually calculating that.
He's the next level.
That's what I'm just going straight to that.
Okay. So what did you do?
Rise 3, go down like to left 2,
Okay.
and then you do the same thing again. I just like the first time I did it to go from each.
So you would have went up 3
Yeah.
and over 2.
Yeah.
Okay. So while that's nice on the graph, sometimes we can't always graph everything. So what actually we're going to do algebraically is very similar to what you're talking about.
A y minus.
So we're just going to start with the same equation. X1 plus X. Actually, Ryan said he knew where to go with this. I thought you said you had an idea.
Yeah.
So what's your idea?
Maybe it's not a good idea. So,
You never know until I put it down.
okay. My idea was that we would isolate for the y, but
Well, isolate for what y though?
the y could, well,
Sorry, Jordan?
You would find x and y too, because you already have. It's more confusing like this. Could you just do like x, do the two ones separately? Yeah.
You can do it separately. So I just wanted you to put it all together because
But basically, the first thing.
sorry, I just want to stop this for now. I'm not getting all the attention over here that I need. Sorry, say that again, Jordan.
So you put your midpoints in where it says m,
Right.
and then the first coordinate would have to equal to 8. The second one would have to equal to 5.
Yeah. So since we're given a midpoint, right, we'll just plug that in as our coordinates. But we don't have one endpoint. Does it matter if we call it x1, y1 or x2, y2? Doesn't really matter, right? It's just one endpoint.
we have to solve it algebraically.
So here I'll just call this one xy, and that's y1. Right, that's one of my endpoints. So here it's 10. Do I know x2? No, that's what I'm really trying to solve for. Right, because I don't know the other endpoint. Over 2, comma y1, and here is 2, plus y2, over 2. So again, just take the information that we know and just plug it in. Now here's the connection that you need to make in solving this. What coordinate is that? That's our x coordinate, right? What's our x coordinate on the right hand side? It's this whole thing, right? That whole thing, there's our x coordinate. So we have 8 should equal to 10 plus x2 over 2. Over here, this is our y coordinate. What's the y coordinate on the other side? The equal sign.
So confused.
This whole thing here, right? You gotta keep in mind, this is just the coordinate, x comma y. We have two coordinates that are equal to one another, so the x of one coordinate must equal the x of the other coordinate. Y of one coordinate must equal y to the other one. So over here we got 5 is equal to 2 plus y2 over 2. And now we're just solving for these two little equations. So how can I solve for the one in blue? The one on the left.
Yeah, so what's S?
That's at my 5.
Look at that. Multiply it by 2. The only
Now
way-
multiply both sides by 2. So you got 16 is equal to 10 plus x2.
So we get 16 all to
It's broke already.
Right? Multiply both sides by 2. And how do I isolate for x2 now? Elizabeth? I can isolate for x2.
Now you bring over the 10.
16.
Subtract. Oh, okay, yeah, subtract.
Subtract 10 from both sides. So we got x2. So x2 is just 6. And from the y coordinate, we got, we'll multiply both sides by 2, same thing. So we got 2 plus y2. And now I'm going to subtract 2 from both sides. So y2 is equal to 8. Right? So therefore, the other endpoint is 6, comma 8. And if we did what Michael suggested to begin with, we would have got that same coordinate, right?
Could we do the slope or?
So you recognize this is really what we're doing is the slope in here. Right? We're seeing the difference of their x, and we're actually multiplying by 2. This is where you see that multiplying by 2 comes in, because everything is halved, multiplied by 2. So we're actually taking that one part of that slope, the x value, and doubling it to get that other x coordinate. Same thing with the y. Okay, not a very exciting lesson, I know. But the concept should be basic. It's just plugging in our numbers. Yes, Dale?
Use a different formula.
What's the other formula?
It's like if you use the endpoints, that the midpoint coordinates times 2 minus the value of the end coordinate.
Sorry, say that again.
It's the same thing with
It's the same thing. Oh, I know. I see.
You just
Right.
multiplied by 2 times
It's
by
just
1.
Ready? I got it.
Oh, so you're taking each of these multiplied by 2.
Yeah.
Yeah, I mean that's what we're doing at the end. So yeah, you could do that as well.
That's
Tricky part is are you actually going to remember to double your x coordinate and your y coordinate?
That's how it works.
But that's how it is. You can see that's what we're doing here, right? We got 16 and we got 10.
Plus. What if we took the difference between the midpoint and the endpoint, which is 2, and then subtract 2 from that, which is 6?
Well, do you see that we're actually doing a difference here as well? So I mean, a lot of the stuff you guys are saying, you're explaining the equations, really.
But like 10 times faster.
If it works for you, sure.